So, good morning, dear students. Today we are starting with our discussion on probability. All right. So the title is probability. That's the title. And kindly write your name on the top right hand corner of the paper and also your full roll number. These two details, you please write it on the top right hand corner of the class assignment. All right. So the title of the topic, it is probability. So I shall start with the first lecture here, that is based on the type of experiments. Okay, let me take you all to a chemistry lab. Consider hydrochloric acid reacting with sodium hydroxide. Okay, now please tell me, when hydrochloric acid and sodium hydroxide, they are reacting with each other, tell me what is going to be the outcome. It's sodium chloride and water, correct? So you know, when these two chemicals, they react with each other, what is going to be the outcome, the product? Yes or no? What is the chance, if I am asking you, what is the chance that you are going to get salt and water? You will say that I am confident that wherever I am performing this experiment, 100% chance that I am going to get salt and water. Do you agree with me? In the same way, consider the next reaction. Two molecules of hydrogen react with a molecule of oxygen, giving us two molecules of water. We have learned it in our chemistry class. So under the suitable experimental conditions, hydrogen and oxygen, they react violently to give water as the product. But if I am asking you, when hydrogen and oxygen, they are reacting with each other, what is the product? I can say that under these suitable conditions, it's going to give you water as the product, correct? So again, if I am asking you what is the chance, you will tell me that it is 100% chance that this is going to be the outcome. These types of experiments where I am having a certainty with what I am going to get, I call them as deterministic experiments. I'm very confident that this is going to be the product. Okay, but consider the experiment that I am rolling a dice. When I am rolling a dice, I very well know that the possible outcome, it is either 1 or 2 or 3 or 4 or 5 or 6. But if I am asking you what is going to be the outcome, you can say that the outcome I cannot say, but there is a chance that I may see a 1 or a 2 or a 3 or a 4 or a 5 or a 6. I am talking about another aspect here, chance. Did you get me? So when I am trying to quantify this chance part, there I am bringing in the concept of probability. So probability comes into picture when I am trying to quantify this chance element. I told you that this is the chance that it's going to happen so and so. So how are you going to express it in numbers? For that, you are going to use this concept of probability. I call this 1, 2, 3, 4, 5, 6. When I am rolling a dice, 1, 2, 3, 4, 5, 6. I call them as the set of all possible outcomes. I call it as the sample space. Sample space is nothing but that set that indicates all possible outcomes. 1, 2, 3, 4, 5, 6. That's called as the sample space. Now, in this sample space or within the sample space, I will be defining something called as the event. Okay. So sometimes the event may be like, what is the chance that I'm going to see an even number? What is the chance that I am going to see a prime number? What is the chance that I am going to see a multiple of 5? what is the chance that I am going to see the number 8? I'm going to see the number 8. Like that, I am defining events in this case. Did you get me? So tell me, what is the chance that when I am rolling a fair cubical dice, I am going to see the number 8? What is the chance? The chance is 0. So when it comes to 0, I will say that it is an impossible event. Did you get me? Same way, what is the chance that I'm going to see an even number? I can quantify that. That a prime number, I can quantify that. That it's a multiple of 5, I can quantify that. When I do that quantify or quantification thing, I am basically considering the probability aspect into picture. So I just talked about sample space, and within the sample space, I'm talking about the events here. Okay, now coming to the point, please listen carefully. Coming to the point, probability that an event E happens, P of E, is given by the classical formula. Probability that the event E happens, in the denominator, it will be talking about total number of outcomes. Okay, it will be talking about the total number of outcomes. And in the numerator, I will be saying number of favorable outcomes. Okay, so I can see probability that an event E happens is guided by this equation, number of favorable outcome divided by total number of outcomes. Okay, so this is that basic formula that you have to keep in mind when you are doing questions on probability. Probability for a certain event, certain means I know this is going to be the outcome. Probability for a certain event is 1. Probability for an impossible event, it is equal to 0. So this probability of any other event, it will always lie in between 0 to 1. It is always lying between 0% to 100%, which means I cannot have a negative value for P of E. I cannot have a value which is greater than 1 for P of E or greater than 100% for that P of E. So please make a note of this. Okay. Now, the next thing that you all have to be aware of, it is, suppose I say probability of an event E, it is equal to 2 by 7. Let me say probability that the event E happens, it is 2 by 7. So can I know what is the probability that the event E does not happen? P of E bar is 1 minus P of E, and that is nothing but 1 minus 2 divided by 7, and that I know it is equal to 5 divided by 7. Okay, so make a note of that input. Probability that the event E happens is 2 by 7. So E does not happen is 1 minus P of E. That I will say 1 minus 2 by 7, which is 5 by 7. Is it fine with you? Now I will even talk to you about the fundamental principle of counting. Okay, so I'll just type these details here. Fundamental principle of counting. Okay, so I request you people to please write this fundamental principle of counting. Okay, so make a note of this fundamental principle of counting. I'll tell you what this is all about. Okay, what is this fundamental principle of counting? What this is all about? I shall quickly mention. Okay, so please note this. What it is, I shall just tell you. So fundamental principle of counting. Okay, so here we have to focus on two things. Fundamental principle of counting. One is multiplication, the other one is addition. So please make a note of this fundamental principle of counting. Two things are there. The first thing we will discuss, fundamental principle of counting, addition, fundamental principle of counting, multiplication. So I'm writing those details here. Okay. So first one is addition. One second. Addition. And on this side, I will be writing fundamental principle of counting, that is multiplication. Okay. So please make a note of this. We have addition and also multiplication. Okay. What this is all about, we will just see. Okay. So consider that there are two tasks. task number 1 and task number 2. Let me say task 1 can be completed in m number of ways. And let me say task 2, it can be done in n number of ways. Okay, then as per fundamental principle of counting addition, I will say task 1 or task 2 can be completed in m plus n ways. Okay, task 1 or task 2. I am using the word or. So task 1 or task 2, it can be completed in m plus n ways. In the same way, task 1 can be completed in m ways, task 2 in n ways. Task 1 and task 2, it can be completed in m into n ways. So please make a note of this. When the logic is and, then you have to opt for multiplication. Listen, when the logic is and, you have to opt for multiplication. When the logic is or, you have to opt for addition. Okay, so task 1, task 2, we have got 2 tasks. Make a note of this very carefully. We have got task 1 and task 2. We have got 2 tasks. The input says task 1 can be done in m ways, task 2 in n ways. Then task 1 or task 2 can be done in m plus n ways. Task 1 and task 2, it can be done in m into n ways. We are going to see all these things through examples now. So, any confusion so far? Is it clear to all? Okay, if so, then let's go to the questions. Okay, let me take the first question. Just stay online. Let me take the first question. I'll take the first 2 questions, okay, from your handout. So, these are the 2 questions. Okay, the first 2 questions from your handout. So, this is the first question. When a cubical die is rolled, find the probability of getting an even integer. So tell me, when a cubical die is rolled, what is the sample space? The sample space, the set of all possible outcomes, you know, it is 1, 2, 3, 4, 5, 6. So the probability of getting an even integer is the question. So the set of all possible outcome, you know, it is 6. In that, can I know what is the number of favorable outcome? You seeing 2, or you seeing 4, or you seeing 6. That is nothing but the even numbers under consideration. So, what is the probability that's going to be an even number? I know the total favorable outcome, it is 3. Out of total number of outcome is 6. So, 3 by 6, which is 1 by 2. So for the first question, the answer is 1 by 2. I will say if the dice, it is unbiased, there is a 50% chance that I end up seeing even. Do you get me? I end up seeing an even number. Okay. Let's focus on the next question now. If a card is drawn from a pack, find the probability of getting a king. I very well know that a pack of cards, it consists of how many number of cards? 52. In this 52, I will say 26 of them, they are red cards, and 26 of them, you know, they are black cards. Correct? Out of this 26 red cards, I am again splitting them into 2 categories. What are they? The first one is hearts, and the second one, I call it as diamonds. Okay, so there are 13 hearts and 13 diamonds. Correct? In the same way, when I am going to the black cards here, again I can split it into 13 and 13. One I call it as club, and the other one I call it as spade. Correct? No? Club and spade. 13 club and 13 spades. Like that, the split up goes. What about this 13? If I consider it 13, it will come like A, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, and Queen. Correct? So altogether, these are the 13 cards that I am referring to. So Can you tell me altogether that there are 52 cards? Out of this 52 cards, how many kings are there? 4 kings are there. King of hearts, king of diamond, king of club, king of spade. Okay, so 4 favorable outcome. So my answer will be 1 upon 13 in this case. I guess this is clear to you. Okay, so I'm just writing all these details for you. For solving some other questions, these inputs will become useful for you. Okay, so make a note of that. So the first 2 questions from your handout I have discussed. Let us continue our discussion further. This is the next question that I am going to select, question number 8 in your handout. Okay, so have a look at this question. A box contains 20 bulbs with exactly 1/4, 25% is 1/4 of them are defective. So totally you have got 20 bulbs. Out of this 20 bulbs, I can say 1/4, 25% is 1/4, 20 into 1/4. How much? 5 of them, they are defective. And I can thus say that 20 minus 5, 15 of them, they are in healthy condition. Correct? Now, from this 20 available, 2 bulbs are chosen at random. So, how many ways I can select 2 bulbs out of 20 available? It is 20C2. In permutations and combinations, we have learned out of 20 available, I have to choose 2 at random. That can happen in 20C2 ways. Now, I can see that the total number of outcome in this case, that is 20C2. In that, can I know what should be the probability that both are not defective? What should come in the numerator? Please let me know. They say both are not defective. So what should come in the numerator? Okay, you may say it is 15C2, but I will say 15C2 is not fully correct. Okay, for answering this question, first I will tell you, I will find what is the probability that both are defective. Let me find out that. I will find out what is the probability that both are defective. So can you tell me what is the probability that both are defective? That will be 5C2 divided by 20C2. Now the question comes, what is the probability that both are not defective? So what should be my answer? 1 minus 5C2 by 20C2. This is going to be my final answer. Okay, and this is not equal to 15C2 by 20C2. Why? Because when I asked you, both are not defective, when I am telling you, it does not mean that both should be healthy. Listen carefully, when I say both are not defective, does not mean that both should be healthy. One is defective, the other is healthy. That is also pointing to the possibility that both are not defective. Did you get me? I will give you another analogy. Imagine a situation. One of my friends called me yesterday and told me that she is blessed with twins. She is blessed with twin babies. Then she told me that both are not boys. She is blessed with twin babies. Then she told me that both are not boys. Does it mean that both are girls? No, there is a possibility that one is a boy, one is a girl. Did you get me? So, take that into consideration. When I say both are not defective, there is a possibility that one is defective, one is healthy, or both are healthy. So, just 15C2 by 20C2 won't be sufficient. So, you first to find out what is the possibility that both are defective. That is 5C2 by 20C2. 1 minus that will fetch you the answer. I guess this is clear to all. Okay. Let's now go to the next question from our handout. Okay, have a look at this question. I need to mention something more here. This is the 9th question. Recall P of A union B is equal to, that is probability that A or B happens. It is probability that A happens plus probability that B happens minus probability that A and B happens. This is in line with the small equation what we have learned sometime long back, that is n of A union B. I hope you all remember n of A union B. It is equal to n of A plus n of B minus n of A intersection B. Okay, so this is an extension to what we just saw. P of A union B is P of A plus P of B minus P of A intersection B. Okay, so make a note of that input now. Coming to the question that is asked, we are talking about mutually exclusive, we are talking about independent. A and B are mutually exclusive means probability that A and B happens, it will be equal to 0. Mutually exclusive means what? Happening of A will prevent happening of B and vice versa. Both will not happen together. So P of A intersection B will be 0 when the events are mutually exclusive. When the events are independent, please be aware P of A intersection B, it will be equal to P of A into P of B. Okay, so probability of A and B, it will be nothing but the product of individual probabilities when the events are independent. When the events are mutually exclusive, then I can say P of A intersection B, that will be equal to 0. Tossing a coin, probability of heads and tails. What is the probability that you are going to get heads and tails? Please answer me. When you are tossing a coin, what is the probability that you are going to get heads and tails? It's going to be 0. You don't get heads and tails. So same way, when A and B are mutually exclusive, P of A intersection B will be equal to 0. Same way, P of A intersection B is equal to P of A into P of B when the events are independent. Now, coming back to our question, the first part, we are considering the mutually exclusive scenario. Okay, when the events are mutually exclusive. Let us look at this scenario. I know that P of A union B 0.6, it is equal to P of A, which is given to be A, plus P of B, that is 0.3. Minus P of A intersection B is there, but that is equal to 0. It's a null set. Okay. So can you tell me what is the value for A then? 0.6 minus 0.3, that is equal to 0.3. Can I not write 0.3 as 3 by 10? Okay. So that is the probability that the event A happens, 3 upon 10 or 0.3. There is a 30% chance that A will happen. But this is the case when the events are mutually exclusive. Now let us focus on the second scenario wherein the events are independent. Okay, when the events are independent, okay, events. So there you are going to use the next equation which I have written there. Let us consider probability of A union B. What it is? 0.6. It is equal to probability that A happens plus probability that B happens minus probability that A and B happens. That is A into 0.3. It will come. Do you agree with me? Okay, 0.6 is equal to A plus 0.3 minus A into 0.3. Okay, so from this, I can see that 0.3, it is equal to A minus 0.3A. That is equal to 0.7A. Agreed? And from this, I can say A is equal to 0.3 by 0.7, which is nothing but 3 by 7. Do you agree with me? 3 by 7. So that is for our next question here. I guess this explanation part is also clear to you. Okay. So let's focus on the next question now. So here we go. When 3 dice are thrown together, okay, when 3 dice are thrown together, what is the probability that you are going to get an odd triplet? So when one die is thrown, it's a cubical die, you can see that there are 6 outcomes. Okay, when 2 dice are thrown, can you tell me how many outcomes are there? 36 outcomes are there. What are those 36? Can you tell me? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, etc. 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. Consider the scenario when 3 dice are thrown. Can you tell me what will be the total number of outcome? 6 into 6 into 6, 216. Altogether, you have got 216 outcomes. So, when 3 dice are thrown together, the total number of outcome is 216. In that, they are asking you, what is the probability of getting an odd triplet on them? What is this odd triplet? 111, 333, 555. So the total number of favorable outcome, it is 3 divided by total number of outcome, that is 216. So 3 divided by 216, which is as good as 1 divided by 72. This is going to be the answer. The probability that you are going to get odd triplet 111, 333, 555, it is just 1 by 72. Did you get me? Okay. So that is the answer for the next question. Let us now consider another one. Look at this. A and B, they are participating in a competition. The 13th question. Okay. A and B, they participate in a shooting competition. Probability that A hits the target, I will call it as P of A. What is it given? 2 by 5. Probability that B hits the target, how much it is? 5 by 7. The question is, find the probability that only one of them hits the target. Only one of them hits the target. That's the question. Okay. So can you tell me what is the probability that A will not hit the target? 1 minus 2 by 5. That is equal to 3 by 5. Can you tell me what is the probability that B will not hit the target? 1 minus 5 by 7. That is 2 by 7. It comes like this. Agreed? Now the question is, find the probability that exactly one of them hits the target, like only one of them hits the target. That is P of A intersection B bar. A hits, B misses. Or what is the probability that B hits and A misses? Like this, you have to answer. Exactly one of them hits means one hits and the other must miss it. Only then exactly one is going to hit the target. Okay. So P of A intersection B bar, that is P of A into P of B bar, that is 2 by 7. Or P of B intersection A bar, what is that? Probability that B hits the target and A does not hit the target. Can you tell me what will be the final answer here? 5 3s are 15 plus 2 2s are 4. 15 plus 4 is 19 and in the denominator I have 35. So the answer will be 19 upon 35 in this case. Explanation, is it clear? 19 upon 35. This is going to be our answer. Is it fine? Okay. Now let's go to the next question. Wherever screenshot you want to take, I request you please take that. That's perfectly okay. Okay. Look at the next one. In a calendar year, 2 years are chosen at random. The question 15 here. Can you tell me a calendar year? It starts with which month and ends with which month? It starts with the month of January. It ends with the month of December. So, how many months are there altogether? Please answer fast. How many months are there altogether? Yes, altogether we have got 12 months. 2 months are chosen at random. So, how many ways can you do it? 12C2. This is going to be the total number of outcome, 12C2. Agreed? In this 12C2, they are asking you, see, when I say 12C2, January, February will be there. January, October will be there. January, December will be there. Like that. Order is not important. You are choosing 2 months. That you can do it in 12C2 ways. In that, the question is, what is the probability that these two selected, they are consecutive? Can you tell me consecutive means what? Jan, Feb, continue. Feb, March, March, April, April, May, May, June, June, July, July, August, August, September, September, October, October, November, November, December. Don't consider December, January, because there the January is referring to the next calendar year. Don't take that. So can you know what is the total number of favorable outcome? 11. So my answer will be 11 divided by 12C2 in this case. Okay, 11 divided by 12C2, how will you evaluate that? That is nothing but 11 divided by 12 into 11 by 1 into 2. And I can see that here, this 11 and this 11 goes off. This 2 will cancel this 12 6 times. And I get the answer here as finally 1 by 6. Did you get me? So there is a 16.6% chance that those 2 months, they are consecutive. That is how we will do this question. Okay. Maybe one last question we will consider before we wind up this session. So look at this question. So we can see that here, look at this question. A, B, C, they are trying to solve a problem. Probability that A solves the question, it is 1 by 3. Probability that B solves the question, it is 2 by 5. Probability that C solves it, it is 3 by 7. The question is find the probability that A and B but not C will solve the problem. Probability that A and B but not C solving the problem. It is probability that A solves it and probability that B solves it and C does not solve. What is C does not solve? 1 minus 3 by 7, that is 4 by 7. 4 into 2, 8, divided by 7 5s are 35. 35 into 3 is 105. The answer is 8 by 105. With this question, let us conclude our today's conceptual inputs and